Okay, let's put on the stream. So before the before we start the class, some announcement. So we will not have a class next week. We will not meet here because I am out of town. I will be out of town for academic conference. The whole week. So Monday, both Monday and Wednesday. So I will upload all those material, course material to D2L. So please try your best to go over those material, and I will also go over them again when I come back. So yeah, but it's better that, but I will go through that maybe quickly. So please before that, try your best to go through all those materials. Okay, that's for next week. And I will so the week after next week, which is 26. So next time I see you, it's gonna be 26, Monday the 26th. Okay, I will also send out those reminder emails through D2L, so that will be fine. All right. Okay, some reviews, revision. Okay, so this we learn about the relations during Monday, right? So a relation is a set of ordered pairs. So we define the relations two different ways. First is we list all of them. That is the most easiest way. Not easiest way, straightforward way, but not easiest because there are a lot of situations you cannot just list everything. So we use the predicate expressions there to define what the element is, what is the constraints you put on the element. And I'm saying the element, I mean the left element and the right element of that pair. Okay, and then we said, how can we define a name, give a name to the relation and define that relation. And here we have two operators. First is the domain, which is the DOM. So it basically returns, so domain and range, which one returns the left hand, which one returns the right hand? Yeah, right. So domain is the thing that returns the left hand element, and range is the operator that returns the right hand element of the pair. I mean, if you put this range and domain in front of a relation, it returns you a set of elements, which are all the left-hand elements or of those pairs. Okay, so if you define a relation, it's actually a set of pairs, right? Like pairs of student, teacher and student. So here we have of you here, so there can be a bunch of pairs, right? If it's a student by, it's a teacher by student, if you use range, it's going to return you a set of students, right? It's going to be all of you, a set of students. But if it's DOM, a DOM, student and DOM plus that relationship, is going to be return the teacher. If there's only one teacher, it's going to be return a set of only one element, but still it returns a set. Okay, they are all set. Domain, like the range, domain, and the relations, they are set. Okay, if you remember those, it's gonna be very convenient for you to do the next exercise. So if you still remember, this example, like OS users are classified by means of sets, non-users, privileged users. The association between users and the files they own is modeled by relation owns over users and files. What expression represents the set of files owned by privileged users? Okay, so I remember we did that last time on that whiteboard. You still remember how do you do that for this example? Yes, I do not have time for you to redo it. I just show you this answer. So first is U users, F is files, and U belongs to the privileged users, and UF belongs to the owns. Also, we have this range here, which actually returns the files because it is a relation over user and file. Okay. I think this is pretty clear. So, all right, let's go over something about today's. Something we want to talk about today. If we still have some extra time, we can get some exercise. All right. Okay, so this is something that is tell you about how can we specify a function of your program. Okay, a little bit about that. So we all learned that two quantifiers, right? The E and the A, reverse E, upside down A, which is there exists, and the other one is for all of the blah blah blah. Yeah. So here we have another two. One is the singular existential quantifier. So it asserts that only one object in a class holds, written as this. If we do it here, A is belongs to the X and the accurator state. So A is an accurator, and the accurator state is functioning. So this part states that the accurate states, A's accurate state is functioning. So A has the accurate state, which is functioning. Okay, and there exists if it's just the existential quantifier, it's gonna be there exists an accurator and whose state is functioning. But here, if we plus this one here, it's gonna be only one accurator is functioning. Okay, can you tell the difference? You can tell the difference, right? One is there exists an accurator which is functioning, but here is alright, so just the difference between these two. Don't want you to get confused. tell the difference, right? This one means there's only one accurate functioning. This one means there is accurate functioning. So only one accurate functioning. So it just states there is accurate that is functioning. If it has more or not, we don't know. Okay, but this excludes that possibility. Only one. All right. So this is very simple. And this omega thing here, the second extra facility is known as the counting quantifier. So just the counting number. This can be easy. Should be easy to understand. The counting quantifier is not a predicate. It represents the number of objects in a class which have a certain property. The counting quantifier omega is used here. This gives the number of communication lines which are connected to reactor 12. Okay, number of lines. So basically, it is not a predicate, so it's not having a true or false value. However, this actually gives you the number. This gives you a number. So remember that. We will use that later. So lines connected. This part remains the same. For this structure, it still tells you that line has connected to this reactor. Has a connected reactor, which is reactor 12. Okay, line is connected to reactor 12, and this gives you the number of lines that is connected to reactor 12. Okay, so is this logic clear? Somebody have question? Anyone has any question? No? No? Good. Okay. So those two quantifiers is something we want. Maybe we need to use them in our in our specification sometime at some point. Okay. All right. So now let's talk about how we will learn all those predicate stuff, predicate calculus. Okay, we'll learn the relations. We'll learn those quantifiers. Now, for the relations, we still need to learn some other operators, but it's okay. We can do this first. So right now, what we want to do, if you still remember why we learned this this whole formal specification thing, at first place, is we want to define our program. We want to define our project with some formal language, which will avoid the ambiguity and it makes everything clear, help with the communication. Okay, but here now let's see, in your program specification you will have to specify a lot of requirements, but if you go into details of the implementation of your program, what is included there? If you want to specify how you implement some maybe class, let's say a class. Okay, let's say a class. We can specify a class with a class diagram. If you know that class diagram in UML. Yeah, I think most of you are familiar. Okay, so if we want to specify, if you want to introduce, okay, this is a class I just wrote, right? And it has this is a class I just wrote. If you want to introduce that class to somebody else, like what is that class about? What will you introduce? Yeah, what will you do about class? So I have a class, right? For this class, maybe a name, right? I'll have a name. I have elements, those attributes, right? Also, what else is in the class? Think about the class diagram.
Operations.
Yeah, exactly. Operations, or you can call it method, procedure, function, things like that. They are basically similar. Okay, so the important thing is the actual code. Most of the code are within that algorithms code that implement those algorithms are inside the block. Sometimes we call it function, sometimes we call it method, sometimes we call it procedure. Okay, so basically that method, it is the thing that actually doing something in your program, right? If you want to calculate 2 plus 2, it gives the function the two parameters, 2 plus 2 or 2 plus 3, give 2 and 3, and you call the function plus, and it returns you a 5, 4, things like that. So it is the function is the code segment that actually do the job in your program. Okay, so the most important thing here is we want to. So there's different ways to describe what is like what this method will do. Like what is input, what is output, input type, output type. Okay, and you describe the algorithm, right? In natural language, it's easy to do that in natural language. Like if we want to describe binary search, something like that. We just say, okay, I'm in the binary search here, what I do. Okay, however, if we want to do with whatever we have already learned, the formal specification thing, predicates, okay, predicates, quantifiers, relations, those things. If we want to define or specify a method with the formal specification, what do you think you can do there? Like here, this is the example. Function of the update procedure. Okay, so just so we can see this is an update function. Okay, so it's to update the value of the global variable system state. Right. So that's what the function do. It's just updating the value of some variable, all right? And the system has one integer parameter, temp, which is a temperature. Okay, if the temperature is greater than or equal to 200, the system state will be set to 0. Otherwise, the system state is set to the value of 1. The system state will have a value range between 0 and 5. Range between 0 and 5. Temperature will range from 0 to 1,000. So temperature will be unaffected by this procedure. So this procedure updates the system state. Okay, and it updates the system state with the value of the temp, with the value of the temperature. Okay, if the temperature is 1 to 100, system state is 0. Otherwise, system state is 1. And some constraints there. Maybe I should separate this part here. It's have some specification that gives you the restrictions on the system state, the value range of system state and the temp. Okay. Okay. So for this update function, okay, try to think about how can we specify it with predicates. Any clue? Because we see a lot of things that is pretty familiar to us, right? like temperature, we have a greater than, equal to. All those things we can represent them as predicates, like the less than, greater, equal to, and we can use and or to connect them. But if it's a function, what shall we do? Okay, so I'll give you a clue. If there's no clue in your mind yet, it's fine. I'll give you a clue. So what we do here to specify this function is, because those predicates, they only returns the true or false, those values, right? But how can we, with the true or false, how can we specify the function? It's hard. So you cannot directly specify the algorithm, right? So in order to specify this function, and we are not specifying any algorithm here with this natural language. We only gave you the input, output of this function, right? So when we specify the function, we use two different predicate expressions. One, with first predicate expressions, we specify the precondition of the method. With the second predicate expression, we specify the post condition of the method. Precondition and post condition. Okay. But what exactly is precondition and post condition? You can make a guess. Like precondition is something that the system has to meet before the execute of this procedure, right? And post condition is something the system needs to meet after the execution of this method, right? Okay. So we use this to create a specification to satisfy this formal specification to satisfy whatever in this whatever that's expressed by this natural language. Okay. Yeah. So the formal definition of a precondition and post-condition is on page 88 of your INS book. So the precondition, it relates to the value of global variables and the parameters before a program is executed. And the post-condition, it relates to the value of global variable and parameters after a program has been executed. Okay. So the values of global. So we have to meet some conditions. And this condition is related to all those variables. So here, how many variables do we have here? Don't tell me you don't know. Yeah, it's two. One is system state, and one is the temp. Okay. Now we know we want to specify what has been made before the execution, what should be made after the execution regarding system update, system state, and the temp. Okay, so from the specification here in these two paragraphs, what value should the system state and temp meet before the execution of this method? Write it down. Yeah. So the precondition. Now we want to specify this whole method, and by doing that, we need two expressions. The first is precondition expression. The second is post-condition expression. They are all predicates, predicate calculus. Okay, and those predicate calculus state some conditions you have to meet, and the conditions regarding the those variables. Yeah, something about the variables you have to meet before and after the execution. Okay, let me give you a simple example. Right, so before the execution of a plus, you should have like two. If we have plus, if we have function that help you calculate the plus of two integers, first you need to make sure they're integers, and then you have to make sure they're within the range, and after that you should have something that returns, and it is actually the sum of the two integers. That's a pre and post condition of that plus. But here it's a update function regarding the system state and temperature here. Okay. So it's going to be something related to system state. Okay. Maybe system state. Blah 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 should be blah 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 blah. I believe it's system state should be blah blah blah, and temp should be blah 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 blah. But what are all those things I omitted here? Before the execution. Before the execution. Okay, let's see them one by one. All right, so for the system state, do we have to meet any requirements for the system state before the execution?
It has to be between 0 and 5.
Yes, great. It has to be greater or equal to the what is that? 0 to 5, right?
Yeah.
0
And then this should be
and system state should be less or equal to 5, right? Okay, less or equal to 5. And how about the temp? What should happen to temp? This is 1. How about temp? Okay, I think you should already know, because if we specify the system this way, the temp is here. It says temp will range from 0 to 1,000, right? So we need to write down this 0 to 1,000 thing for temp, and temp is less or equal to 1,000, right? And those are the two conditions relate to system state and temp, because there are only two variables here, right? Two variables here, so there are two parts in this precondition, and for all these parts we want them to meet simultaneously. So we need to connect this system and the temp with and or. Which one do we use? Right? We specify that the system state has to meet some conditions. We specify that the temperature has to meet some conditions, right? Okay, we specify some conditions for both variables. But now, what can we do with this two?
automated AND statement.
Yeah, we combine them with an AND, because those two have to be met at the same time before the execution. Okay, So here what we do is we change the comma to and. Okay, so if you want this more clear, we use the brackets to separate those two parts. Okay, so the system state greater or equal to 0 and the system state less or equal to 5, temperature, blah blah blah. Okay, so given this precondition, let me know the post condition. Think about the post condition. Post condition is also something about temp and system state. Okay, try to specify that. What should the temp looks like after the execution? What does this description say about temp? You can find. Yeah, exactly. See the last sentence here. Temp will be unaffected by the procedure. Okay. Temp will not be affected by the procedure. So we want to specify that. So we kind of use a temp prime equal to temp. So temp remains the same. So we use temp prime to represent the temp after the execution. Okay, the value after the execution. Okay, and we use system state prime to represent the system state after the execution. Okay. All right. So here I give you this temp prime equals to temp and think about this. Now it's time for us to use like here temp equal to that and what else. This is the thing that you need to use a logic now. What do we have there? Let's see. If the system has one integer parameter temp, if temp is greater than or equal to 200, the system state is set to 0. Otherwise, it is set to a value of 1. If that sounds familiar, we saw the keywords if, then, right? So that implies the if. If we say this if, have we seen that a lot? We see that a lot. If, right? If A, then B. A implies B. Okay, but here it should be something similar. We use the implication operator. Okay, so within this parentheses, within this brackets, I'm telling you we have this implication. But what is on the left? What is on the right? Let's look at here. If temp is greater than or equal to 200, the system state is set to 0. Isn't that easy? If, then. Okay, just say it. What is that? If A, then B. We already have, and what is A here? What is B here? A is, if A, then B. Okay, temp is greater or equal to 200. Right, so we put this here. And then system is set to 0. We put them here. However, this is still natural language. The rest of it is we want to convert it into predicates. I think you should know that. How can we translate this sentence to predicates?
Temp is greater than or equal to 200 implies system state equals 0 or exclusive or 1.
Yeah.
System state is equal.
Okay, so here what we do is since we want to do what we want to do is temp greater than or equal to. So temp greater than or equal to 100. 200. Okay. Temp greater or equal to 200. Okay, let me make this pretty clear. Then system state is set to 0. Okay, what do I do with this? Like I told you, can we just do this? System state equal to 0. Can we do this?
You need to put a parentheses probably around it because you're going to specify.
Yeah, that's fine. Parentheses is fine. Yeah, let's make it more clear. Yes, and anything wrong?
There needs to be exclusive or.
Okay.
Another parentheses.
Okay.
around.
No, here. I mean, this part we have some problem here. So system state is a variable, right? If you look, if we go back 5 minutes earlier, let's see, what is a temp?
Variable.
Yeah, we use the. Why do we have this temp prime here?
Because it's unaffected, or it's after the.
Yeah, it's after the execution. We use the prime here. So after the execution, we should also use the system state prime, right? Okay, remember that. Don't forget that. If we want to specify something after the execution on the variables, okay, we need to add a prime there. Remember that. We need to add a prime there, a prime there, a prime there, prime there, prime there. Okay, so that you can remember this. All right. And is that finished the thing?
No.
No.
No. Great. We have another end because we have another sentence here. Otherwise, system state is set to a value of 1. Okay. Okay. System state is set to a value of 1. So it's going to be something similar. What implies what? This means if temp is greater than or equal to 200, the system is set to 0. And this part, we want to say otherwise, system state is set to a value of 1. Otherwise, system state is set to the value of 1. What does otherwise mean?
If the temperature prime is less than, or sorry, if the temperature is less than 200,
Yeah,
implies
means the temperature. If the temperature is greater than or equal to, otherwise means if the temperature is not greater than or equal to. Okay, so not greater than or equal to means less than. Okay, means less than. All right. So temperature less than 200. Okay. That temperature less than 200 implies system state prime equal to 1. Great. 1. Yeah. Okay. Let's double check. Anything wrong here? Or anything we want to modify? Yeah, that's exactly the answer. So it's gonna be good. Alright. So one thing I speak a lot of times, the value of the variable after they execute it, we need to use prime there. We need to add a prime there. Okay. So this means, so combine this precondition and postcondition, we are able to specify this method here, right? So it's basically a combination of those predicates, and there's 2 different conditions, okay? And some trick there is we use a prime there to represent the value after the execution. Okay. And the logic is the same. The if, we say the if stuff, we have this implies. Alright. So this is the very first method that you specify with a formal specification. Any question on that? Please ask quickly. Right? Okay. 2 conditions, postcondition, preconditions and postcondition. 2 types of conditions. And postcondition, preconditions we represent. And all those conditions are regarding the variables. Okay. That is local or global regarding the variables. Alright. Let's see some exercises. If you have your book, let me pick a short one so that I can type them. Okay, if you have this book on page 90, the question number 4 of exercise 4.9. Okay, this is short, so I can just type it here. If you do not have it, let me tell you what is it. So the procedure nouveau has one integer parameter value. The function of new is to increment the parameter by 1. This should be pretty easy for you. Now you have 3 minutes to work on this question. Specify this method with precondition and for postcondition. Okay. Take out your pen and a piece of paper. Try this. Just 2 sentences here. Now let's go back. So precondition. Let's specify what is precondition in natural language. The precondition here in natural language is what shall we? What should the value? What are those? What are the values? The only parameter here is the val, VAL, right? So the post condition and precondition has something to do. Need to have something to do with val. Okay, the new val is not. The new val is not a method. It's not a function. The new val is a function, not a parameter. The only parameter here is val. Right? Only parameter is val. So in the precondition and the postcondition, we need to have something to do with val. What's that? Before the execution, we need to ensure that. What should we make sure? It's something about val before the execution. Can val be a unreal number? Can val be a float number?
It's an integer. So
It cannot be like those float number. It should be an integer, right? It should be integer. So the precondition is something about val. The val should be an integer, right? The val should be an integer. Yeah. So how can we write it down? If you remember, we use this z to represent integer, right? So this is what we actually have. So this is the precondition. Val belongs to integer. Isn't that easy? Okay, now let's go to the post condition. Still something about val. Huh? This? This? Remember that? Like we have an element and a set. If that element belongs to the set, okay. Okay, and post condition, something about val, VAL. Post condition is something happened after the execution. So val, it says pretty clear here. The function of val is to increment the parameter by. The function of new val is to increment the parameter by 1. What is the parameter? Val. So how can we specify increment the val by 1?
val prime equals val plus 1.
Yes. Exactly. Val plus 1. That's why we need a prime there. We need to distinguish the value after the execution and the value before execution. Okay, so in the when you are doing the programming, don't confuse with that. When you're doing the programming, when you want to do something to increment 1 to the value val, you do this val plus plus, or val plus equal to 1, or val equals val plus 1, right? But here, if we're writing this way, the computer knows how to do that, but if we're writing this way, when people are reading them, they don't know which val is the original value, which val is the value after the execution. So we need a prime there. Okay, this is the easy one. Now let's play with a little bit longer one. Let me see which one is more fun. Okay, this is gonna be. Alright. Next. So the procedure. So question number 2, the procedure. Question number 2 of exercise 4.9. The procedure select has 3 parameters. Okay, 3 of them. So that means in the conditions we have to play 3 of them. To play with 3 of them instead of 1. Okay, so the procedure select. Let me quote it to make it more obvious. Has 3 parameters. The first parameter flag is Boolean. Parameter is Boolean. The second and third parameters 8 and vol are integers. If the first parameter is true, then the second parameter is set to the modulus of the third. Okay. So we have 2 parameters here. The first parameter, 3 parameters here. First is the flag, which is a Boolean. Second one is called 8, which is an integer. Third one is vol, which is an integer. So let's see what are the pre and post conditions here. Okay. How many parameters here? 3, yeah. Great, you're on track, every one of you. A little bit. Can you see that from the back? Can you see all the words from the word from the back? Yeah. Text. Yeah. So precondition is pretty easy. It's just something like that. Flag is Boolean. Flag is Boolean. And see the answer. How about 8? 8 is the question here. Okay, flag belongs to Boolean. 8 belongs to Z, yeah. And val belongs to Z as well. All right. Anything else? We miss something? First parameter. 3 parameter. First, second, and third. If the first parameter is true, then the second parameter is set. Okay? Yeah. I think that's preconditions. Okay, then we go to the post condition. Post condition basically it's if the first parameter is true, then the second parameter is set to modulus of the third parameter. So it's a mode. How can we do that?
Prime.
Yeah. Okay. First parameter is true if so it's a flag prime
Equals flag. And
equals flag. Why do you say that? It says if the first parameter is true,
never mind.
Yeah.
Flag.
it will always equal to flag, right? So flag equals to true. Yeah. Flag equals true. If flag is true, then 8. What do we do?
And add implies add prime equals val.
Prime equals to val. So let's see. Okay. Yeah, the second parameter is 8. So if we want to set something 8, it's going to be 8 prime equals to what is the modulus of the third parameter? Anyone knows that? What is modulus? Huh? So if you think that's something you don't know, you can just do this. Because it is actually just so val. Yeah. Val. Yeah. Okay. So it's basically it's gonna be some operations to val. And if you think when you are actually translating some specification, when you made something that you do not understand, yeah, just leave the information there, but with this format so that people knows that this is operator and this is gonna be this is operator, this is gonna be the operands, and they know there's a value here we assign to the 8 prime. Okay, so here this basically translate that information. If the first parameter, then we change the second parameter. Okay, however, if you still remember here we have a condition that temp prime equals to temp, which specifies that temperature is not affected by the procedure. But here, do we need that? Do we need this? Eight prime equal to 8. Do we need this? Do you think so? Yeah, it doesn't say that at all. It doesn't say that here in this procedure description in natural language. So you shouldn't have this here. So this is clearly state that we have this here because it clearly states that temp will be unaffected by the procedure. But here we actually don't know. Maybe this is only part of the procedure description. So if you translate this part, it do not aid information there. Okay, so you just translate whatever information has been put in there. All right. Okay. All right. This is still these three questions, they are similar, but now let's say something more tricky. Okay, last one. This is more tricky. Procedure 8 up has 3 parameters, 1, 2, and 3. Looks easy because it just tells you what are the 3 variables. Let's see what all the parameters are integers, always is range. 1, 2, 3. All the parameters are integer. Arrays with range 1 to 1 to 50. Function of 8up. Function of 8up is to 8 corresponding of elements. Is to 8 array 1 and array 2, then put sum into corresponding element of array 3. On entry to this function array 3 0. Okay, this is a little bit complicated now because we're not dealing with variables, we're dealing with arrays now. Okay, we need to use think about predicates as well as maybe the quantifier. Predicate. We use predicate, quantifier, this one is really tricky. This is the last fun we will have today. I'll give you 1 more minute, think about it. Challenge yourself. The logic is there. You just need, actually you can read the logic, you can understand that logic. Every one of you can understand this, what it says, right? You can understand them, right? But how can we do that? In predicates, with those quantifiers. And also represent precondition, postcondition. Alright, yeah, this is a little bit difficult, but let me tell you the answer step by step. Okay, so first, well, let's see what are those things here. Area 1, area 2, area 3, and precondition probably include that. This is pretty important. On the entry to this function, every 3 elements are all 0 on the entry, which means before we execute it. So every 3 elements are all 0 should be included there for sure, right? For sure. And also the range. The input array with the range 1 to 50, this should be included there, right? So, okay, let me finish this and we should be good. Or, okay. For all the let's define an index I, okay, for R the I, which belongs to 1 to 50, or you can see I. This we can see I integer. This is more clear, okay. All the I integer, and then we can separate it. Let's see, I is like from 0, 0, yeah, greater or equal to 0. I is greater than or equal to 0, and I is less or equal to 50, right? And we'll put a big dot here. Okay, I will put big dot here. Array 3 I equals to 0. Does that make sense to you? Does this make sense to you? That make sense? Explain? Yeah. So first we define for all the I is z. Why I is the integer? Okay, I is integer, and we give a further constraint there. The I between 1 and 50, because we want to represent something that's 1 to 50. Because what in this here, the integer array range from 150. Okay, so that's what we have here. Okay, come on, where is it? Okay, 50. So I is 1 to 50. And we want to satisfy this. Array 3, I equals to 0. So this means on the entry of this function, array 3 elements are all 0. Okay, this makes sense? Does it make sense? Yeah, all the I from 0 to 50, the array 3I equals to 0. You know what is array 3I, right? The ith element of that. Yeah. Okay. All right. Basically, this is the precondition. Yeah. Also, you can put like yeah, something like that. And array 2 and array 3, it doesn't specify anything there in the precondition, right? So we do not have them. Okay. And for the post condition here, let's see what is the question here. The post condition is we call this function add up, and we add whatever in this array 1 and array 2, put them in array 3. You know what that means? Corresponding elements means we add array 1, we add the first element of array 1, the first element of array 2, and then we put the sum into array 3. Similarly, we add the second element of array 1, second element of array 2, and put the result into array 3. Alright, so on, so on, until 50. Okay, so the post condition here. Alright, just to let you know, post condition here is for all the I. Here, this part is exactly the same. We want the I. Okay, and the big dot here. What is that? It's something to do with array 3, right? So the ith element of array 3. Okay, we put a prime here, whatever. Okay, so it equals to array 3I equals to array 3 0 equals to array 1 0 plus array 2 0, right? So array 3 2 equals to array 1 2. So here it's a array 1I. Does it make sense? Makes sense, right? Okay, do we need prime here?
No.
Yeah, no. Actually, it doesn't matter because, but according to the no, we don't want the prime there because according to the description from the question, yeah, and it doesn't specify if the value of array 1 and array 2 change, but if we do this way, it's going to be correct. Okay, let me put it here. Alright, that's a pre and post condition. Okay, let me re-upload this documentation so that you can go back and look back to those questions. Alright, meanwhile, if you have any question, so next week we won't have a class and no office hours, so you can email me. I can reply your email by answering your question. Alright, that's it for today. Thank you very much.